Hello and welcome to this Aim High Live. This one is about how dangerous are fossil fuels really, and this is one of the ones in the environmental series. If you were here last week, then you will have met George Monbiot as part of that same series, and we've been learning about farming and plastic and all those kinds of things. And today we are gonna do fossil fuels. Miz is here, Alec is here, Rebecca's here, Japan Maple is here. Thanks so much for coming, everyone. Right, okay, so to begin with, I wanted to talk to you guys about meerkats. High Vendible Sugar's here as well. Okay, so obviously today is about how dangerous are fossil fuels, really. So let me just grab that so we can keep it. But first, can meerkats talk to one another? Can they communicate with one another? And if so, what kind of level of communication do you guys reckon they can achieve? So are these meerkats just chatting, or are they just kind of rubbing sand off one another's nose? What do you think? Leonardo's here, 1 million slots is here as well. Yes, for anyone who is joining for the first time, I can see some new names in here as well. Thanks for coming. This is an Aim High Live, so you can ask questions whatever you want, and we will cover how dangerous are fossil fuels really, but you can ask any question around that and we'll just go around it. But this is basically part of a series of ones about climate and ecology, because we think that these things need to be taught a lot better if we're going to turn the world around, and we hope that you will take this knowledge and spread it. Miz is saying they're just communicating. Cute. Rebecca's saying, don't they squeal or something if there's danger? Shamil is saying, don't they squeak? It is an adorable photo, isn't it? So yeah, they do squeak, but the thing that's quite incredible is the sophistication of the sophistication of the information that they can pass on to one another. So there were some people who did this test, and they were analysing the squeaks that the meerkats gave to one another to signal for danger when different people arrived. Now, what level of detail do you guys reckon the meerkats were able to discern? Let's give this one a monocle. By listening to what the other meerkats were saying. What level of detail about the arriving danger do you think? Oliver's saying don't use international sign language, which is exactly right, and that's why I'd encourage everyone to learn sign language so that you can communicate with meerkats. 1 million slots is saying, how do you analyse a squeak? Well, to analyse a squeak, it's similar to the kind of technology that you would use when you use Shazam. And for those who haven't used Shazam, it's like an app that you use to listen to music, and it will compress the file into a kind of coded version of the file. So instead of getting like the full musical sound wave, Shazam will compress it into a much smaller byte of information. And then it will send that information to a database, compare it to a database, and so on. And you can use similar things with meerkat sounds, where you can compress the file into something that's a lot easier to analyze, and then try and find similarities between the different squeaks that meerkats make at different times. While people are continuing to say what amount of information they think meerkats can communicate to one another by talking to one another, i.e. when a human is arriving, what kind of level of detail can they communicate to one another? I'm just going to quickly tell you about this. So since we've had Shazam and we've been able to compress musical information and analyze it, we've now become totally certain that since the charts began, the music that occupies the top 10 of the charts in the world has becoming more and more similar to itself. So Shazam has allowed us to prove that pop music basically is getting more and more boring, because the top 10 is just becoming increasingly similar to itself. As the decades go by, all of those top 10 tracks just become more and more sounding the same, which is such a big problem, because there's so much brilliant music out there, and the stuff that's in the charts is such a tiny slice of what is actually out there. And every decade that goes by, it gets even more compressed what stuff is actually featured. Anyway, so Suka is saying, could you learn to make the squeaks? And I don't know if you probably could teach a machine to make the squeaks for you so that you could communicate with the meerkats. I guess that probably would be the case. But anyway, what was found in this study was that these meerkats could communicate to one another enough information to tell one another if the approaching human was wearing, for example, a red shirt. I don't know if they've got exactly red sensitivity in their eyes, but certainly there was color sensitivity in the way that they were communicating with one another, and they were able to talk about whether the human approaching was tall or short and which direction they were approaching from. Now, this is a terrible picture of a human, but anyway, they would communicate. I'm not sure if they'd have enough ability to communicate to say that this human has no hands and no shoulders and an excessively long neck that potentially runs all the way through the body. It is unclear whether they'd be able to communicate this. But anyway, ultimately, meerkats can communicate with way more accuracy than anyone thought was possible until we did this test. Which ultimately contributes to something that we continue to learn, which is that continue to realize, which is that the more we learn about other animals, the more we realize how similar to them we are and how little difference there is between us and them. The more we learn, the more we realize how similar we all are. Let's give this one a monocle as well, since it's also completed its studies. Okay, so here's what I wanted to tell you about. Well, before we go into fossil fuels, because the subject of today, for those joining late, is how dangerous are fossil fuels really. But before we go into that, I wanted to ask you guys about communication and how quickly ideas can spread. So imagine this. Imagine there's one person who knows an idea. They've come up with an idea. If they tell two more people, if that person tells two other people, then three people will know the idea. So another way, and I'm wondering what you guys think will come next. So if those two new people tell two more people each, then how many people will we have? So it'll look like this. You've got the one person who has the idea, and that person tells two people. And if those people then tell two people each as well, then how many people know the idea? So Venerable Sugar is saying 7 exactly, because first we got 1, then we had 2, then we had 4, and what will be the next step? So once 7 people know this idea, how many people will know the idea once these people all tell 2 people? And yes, so now we're going to add 8 people, and so 15 people will know the idea exactly. Rebecca has got it, and Venerable Sugar's got it too. Cool. Okay, so what will come next? So let's do one more. So the idea is spreading. First, one person has the idea, and if everyone tells 2 people, then one person knows it, then 3, then 7, then 15, and what comes next? So remember, the first we added 2, then we added 4, then we added 8, which means now we're going to add 16. And so the next number in the sequence will be 31. We added 2, we added 4, we added 8, then we add 16 to get to 31, and next we're going to add 32, because all of those 16 people are going to tell 2 people each, and so next stage we're going to be at is 63 people knowing the idea. Right, so if this continues, and that every step of the way these people tell 2 more people the idea, how many times will it take before everyone in the world knows the idea? How many stages do we need before everyone in the population knows the idea? So people are asking what kind of sequence it is. Do you guys want to spend, if you want, I'll spend like 30 to 45 seconds just showing you the maths, if you're interested to see it before we move on to the thing about fossil fuels below. Who wants to see the maths of how this works? So Venerable Sugar is saying 20 stages. It's not going to be 20 stages. Okay. Okay, Maddie's saying yes. Right, okay, I'll show you the maths. And Suka's saying 420 stages. Right, so here's how it works. So this sequence here, 1, 3, 7, 15, 31, 63, is, I don't know if anyone has already seen this, but this sequence is 2 to the power n, take away 1. So 2 to the power 1 is just 2 minus 1, which is 1. 2 to the power 2 is 4, minus 1 is 3. So that's this one. 2 to the power 3 is 8, minus 1 is 7. So yeah, 2 to the power n minus 1 is this sequence. Now that is gonna, where n is the number of stages that you've gone through. So here we have n equals 1, n equals 2, 3, 4, 5, 6. Okay, so all we need to do is find out n when this equals the world population, which is, let's just call it 8 billion. So let's stick a good 9 zeros after that. So 2 to the power n minus 1 equals this, which means 2 to the power n equals 8 billion and 1. And does anyone know how to solve that? This is one of the things you do later on in maths, but I'll just quickly tell you what it is. So on your calculator, you've probably seen this button log if you haven't used it already. And this button log means what power do I have to raise 2 by in order to get 8 billion and 1? So 2 to the power n equals 8 billion and 1. What power do I have to raise 2 by to get 8 billion and 1? And if you put that into your calculator, you'll find that it's 33. So you only need, if every single person shares an idea with 2 other people, you only need that to happen 33 times before the entire world knows. Everyone on the planet knows. It is amazing how quickly things spread when people share ideas, and that's going to be very important in terms of how we respond to the threat of fossil fuels. Right. Okay. Let's talk about fossil fuels. So, can everyone please name for me what are the main fossil fuels? List them all out. What are the main ones? And for anyone joining late, just while people are starting to list them, thanks so much for coming. This is Today High Live, and today we are doing how dangerous are fossil fuels really, and you can ask questions whenever you like. I've just asked everyone to start listing out all the fossil fuels. Okay, so we got coal, we got oil, we got gas. This is great. Can anyone think of one more? Because so far you have named 3 of the 4 that I'm looking for. So petrol and diesel we're going to count in oil because they're extracted from oil. So we've got gas or natural gas. And we've got crude oil. And crude oil is where you extract petrol or gasoline, as they call it in the US, diesel, kerosene, all those kinds of things. So they all come from crude oil. And then you've obviously got coal, which is a great one as well. But can anyone think of the other one? No one has given me the other one yet. Or emulsion. I'm not actually sure. I've never heard of or emulsion. That is actually entirely new to me. Great, I'm going to find out what or emulsion is after this. In fact, let me write a note to myself for afterwards, because that is new as an idea. Maybe it's a trade name in one country, but I haven't heard of it before. Anyway, yes, someone just put it. Suka put it. It's peat. So the final one is peat. And peat is one that a lot of people don't really know about, and it's kind of like a really, really nutritious soil. This is a picture of a peat bog where people have dug a ditch to dig out the peat here, and they've dug it out in these big slabs. Now, peat can be burnt as a fuel because it's a fossil fuel, or it's also an incredibly nutritious fertilizer for plants, so it's used to grow food as well. But there are these... The peat runs underground all the way across. Ireland is really famous for having loads and loads of peat. So if you're in Ireland, then I'm sure you'll know about peat already. But Ireland has huge amounts of peat underground, so much so that if it gets very, very dry and someone sets a campfire up or some kind of fire on a field and they don't realise there's a peat bog below, then what can happen is the fire can burn downwards into the peat bog, and then it can burn through, it can make like fiery tunnels underground that can then resurface elsewhere, and there'll be smoke billowing out, and basically you can create these tunnels of fire underneath Ireland by setting the peat bogs on fire if you're not very careful with where you set up campfires. So that's something to be aware of. In fact, similar story to that, I don't know if anyone's heard this before, but in the USA I heard about a case where a private rubbish dumping company, and obviously like private companies doing something like this is often a bad idea, but a private rubbish dumping company that was allowed to just dump a load of rubbish into old coal mines. They just dumped loads and loads of rubbish into old coal mines, and then because they were running out of space, they just set the rubbish on fire. And obviously it's in a coal mine, which is full of coal, and so when they set the rubbish on fire, it just kept burning underground and just did not go out, and you had these huge holes that were sucking oxygen down into the fires. And underneath this town, the ground was so hot that I think there were like panels being blown off at the petrol station as the petrol kind of heated up and was threatening to explode. I'm not actually sure what happened with that, but yeah, there's some really irresponsible treatment of coal mines somewhere in America. Anyway, so yes, these are the four main fossil fuels. Well done for figuring them out. Which one? So let's exclude peat, because peat is kind of like a fringe one that most people don't really consider, because doesn't take up a huge part of the fossil fuel market, and it's not really burnt for fuel very much, although it is another one that really needs preserving, because these peat bogs are great places for wildlife as well, and also we really, really don't need to be burning more of this peat to put even more CO2 in the air. Right, so of these three, gas, crude oil and coal, which ones do you think are the worst and why? Which are the worst and why? So which are the worst of the fossil fuels and why do you think so? Okay, so we're getting quite a mix here. Suka's saying coal, Venerable Sugar is saying coal, Miz is saying crude oil, Alec is saying gas, Suka's saying because of the smog, Japan people are saying oil because of fracking, and 1 million slots is saying oil is one of our best. Okay, so there's a bit of a spread. Let's go through them one by one. So gas is definitely the cleanest of them all, because gas, when you gas is mainly made up of methane, and methane is a tiny chemical that is a very, very bad greenhouse gas in itself. And so if you just release methane into the atmosphere, then you're doing even more damage to the planet than if you burn it. So gas is normally found anyway when people find oil wells, and so gas is a strange one that actually, if people are going to continue to find crude oil, then we should definitely use the gas, because the alternative is just allowing the gas to be released into the atmosphere, which will create even more global warming. So gas is a strange one where actually it's kind of better to burn it. But the problem with gas is that it's so difficult to transport because you have to compress it. It's nowhere near as easy to transport as a solid or a liquid because it's a gas. And so a lot of, you might have seen and wondered why a lot of oil rigs have a huge flame coming off the top of them. And a lot of oil rigs are banned from doing this now. But oil rigs traditionally used to burn off all of the gas as it came out, because it was just nowhere near as profitable for them to, here's an oil rig on the sea, it was nowhere near as profitable for the company to sell the gas, because they had to transport it. They just wanted to get the oil out and sell that. But now it's illegal for most oil rigs around the world to flare. It's called flaring, because it's so wasteful, and they're forced to pipeline it to places where it's going to be used. And so gas is definitely by far the least bad fossil fuel, in the sense that as long as the other fossil fuels are being as long as crude oil is being taken out of the ground, gas might as well be burnt, although it would be better if none of them were taken out of the ground. Oh, and Leonardo is saying flare as well. Yes, exactly. And Japan Maple is saying, or just leave the gas and oil in the ground. Right on. Yeah, totally agree. That would be the best thing. Okay, so between crude oil and coal, which is the worst? It's difficult to say because coal burns with... Coal is a very big molecule. It's a huge molecule that doesn't burn very effectively. Sorry, this is a zoomed in molecule, and these are like supposed to be pieces of coal. Not very good drawing, Matthew. It looks like a... ghost eating spaghetti. Anyway, let me just turn it into the ghost eating spaghetti that I was always hoping to be. So yeah, coal is particularly bad because that huge molecule burns very inefficiently and will release loads and loads of tiny particles of unburnt fossil fuels into the air, which create this smog, which is not only can contribute to global warming, but also will be hugely polluting both for respiratory systems, so like the ability to breathe of people and animals, but also can be very polluting in other ways as well. So coal is very, very bad in that sense. And in that sense, it's worse than crude oil. But the thing that's so bad about crude oil is how good it is. The problem with crude oil is that it is such a good fuel. We've not found anything as good as it yet in terms of something that is liquid, so it's easy to... And when I say crude oil, I'm really meaning like the purified version. So let's focus on petrol or petroleum gas, whatever you call it. In the UK, it's called petrol, but in the US, it's called petroleum gas. So let's just call it petroleum. Petrol is a brilliant fuel. It's liquid, so it's not only really easy to transport, but it's really easy to move around inside an engine to where it needs to go. It's incredibly energy dense. What does it mean that it's energy dense? What do you guys think? And Japan Mobile is saying crude oil is used to make plastic, which pollutes too. Yes, exactly. So higher energy density, more efficient. Oh, Rebecca Coleman's got a great answer. It means lots of energy to in a small amount of it. So you don't have to carry much petrol in a tank to have a huge amount of energy stored. If you compare that to the most powerful batteries that we have, then the energy density of the best batteries is still only about... I think it's about a quarter. It's somewhere between a tenth and a quarter, and I can't remember exactly the right amount, but still, batteries are still a tiny fraction of the energy density of petroleum and other liquids that you can get from crude oil. So we just can't get the energy stored inside something light enough compared to petroleum, and that's another reason why petroleum continues to be so popular. Can anyone think of another thing that makes petroleum a good fuel? And when I say good, I'm not talking about good in the sense of the long-term survival of our species and the long-term survival of the biosphere in a stable state. I'm talking about good in the sense of people just trying to go about their daily lives, i.e. the bad kind of good that is ruining everything. Cheaper, exactly. So one of the biggest things that is good about petrol is that it is cheaper. So what you have is this very cheap, very easy to use fuel. I should say cheap. It's very cheap, easy to use fuel that's liquid. It's easy to use it to move it around. It's very energy dense. No wonder petroleum is so popular, and that is why I would personally say, although it comes down to your personal opinion now, but I would personally say that crude oil is the worst fossil fuel because it is such an in-demand fuel, and people will go to unbelievable lengths to get it out of the ground, drilling in the Arctic Ocean, drilling in areas of Australia just off the Great Barrier Reef, where clearly it's a safe harbour of the largest amount of ocean biodiversity, I think, in the entire world. People will go to insane lengths to get this stuff out of the ground to try and benefit the human race without consideration of the long term. And that's why crude oil is so dangerous, because it's such a good fuel. Right. Okay. So we've talked a lot about the problems, and we should quickly go over why these things are so bad, even though a lot of you will already know. So these things are bad fuels because they release huge amounts of carbon dioxide. Now, a lot of you will already know this, but just so I'll just really quickly explain. In fact, before I explain, I want to show you this. So this chart is showing you the increase in CO2 year on year. What do you guys think? This is up to date, so I've grabbed some data from I think it was today or maybe yesterday. What do you think has happened since the pandemic began, since the lockdown began? What do you think has happened to this trend in CO2 levels? What do you think has happened as we've moved into 2020? And while you guys are telling me what you think there, I'll just quickly talk about CO2. So for those who don't know, carbon dioxide is a powerful greenhouse gas. That means that it will get caught up in the atmosphere. So if this is the Earth, then you've got the atmosphere surrounding the Earth. Let's do it in this yellow colour. And the atmosphere of gas surrounding the Earth contains a mixture of gases, mainly nitrogen, mainly oxygen, neither of which are greenhouse gases, but carbon dioxide is. And so the carbon dioxide that's created lingers in the upper atmosphere. Well, no, not in the upper atmosphere, but the carbon dioxide lingers in the atmosphere. And here it traps the heat from the sun. So the sun's energy shines in as radiation, and this heat radiation enters the atmosphere. It enters with a slightly different frequency, which is why it can get through the greenhouse gas, but very unfortunately for us, it leaves with a frequency that is trapped by the greenhouse gas. The carbon dioxide absorbs this heat, and then instead of it going back out, the carbon dioxide re-radiates a lot of it back towards the Earth. True, some of it will radiate out, but it radiates a lot of it back towards the Earth, and so overall, the extra CO2 in the atmosphere will heat up our planet. And there are other greenhouse gases as well, but of course, it's fossil fuels that have contributed the most by miles to the greenhouse effect because of the huge amount of CO2 they've pumped out. Now, consider the fact that methane is a way worse greenhouse gas than CO2. And even with the amount of methane that is being produced by agriculture, especially ruminant farming, which means beef and lamb, but still, even with methane being a way more potent greenhouse gas, fossil fuel burning is still by far the biggest contributor to climate change on our planet, because they have simply produced, the fossil fuel industry has produced so much CO2. Right. Okay, so this is the trend of CO2 rising year on year. Now, what do people think has happened since the pandemic? I want to see what people think. So Japan Maple is saying that is rather steep, and I agree, it's maddeningly steep. You guys should go on co2levels.org after this lesson. It's run by the 2 Degrees Institute, which is a great organisation. But co2levels.org, and work out what the CO2 level was on your birthday, because then you can tell people that you're born at that ppm of CO2. That's what I tell people. What is my birth CO2? I can't remember exactly what it is. I've written it down on it's on my CV. Anyway, yeah, so you should check out your birth CO2 level. But still, it's gone from 380 not very long ago up to where it is now. And Suka thinks it's slowed down. Japan Maple thinks it's decreased. Jeff Panic thinks it's maybe doubled. Venable Sugar thinks decreased. So there's a lot of people saying they think it's decreased because there's fewer planes and cars going around. And okay, oh, you guys are talking about Phil watching this. Is Phil watching this? Oh, I hope so. Anyway, so yeah, as the I'll show you what's going to happen. So this is what has happened since the pandemic. Nothing. There has been absolutely no slowdown in CO2 levels since the pandemic began. A lot of people were expecting there to be a bit of a slowdown because a lot of people saw those maps that were going around which showed nitrous oxide, so that's often shown as NOx because it can be NO1, NO2 and so on. So there are a lot of maps going around of nitrous oxide showing the decrease in nitrous oxide levels over China and northern Italy and so on towards the beginning of the pandemic, and people were saying, whoa, there's like loads less pollution. And it's true that there was less pollution of things like nitrous oxide, but overall the CO2 levels are still continuing to climb extremely rapidly. And the lockdown has made basically no no dent in this. I think what the lockdown has done, I hope, is started to change people's attitudes about the fact that we can completely turn the world around and we can completely reinvent the way we live when we need to, and when there's the political will to make it happen from the top. And until that political will exists, we'll just continue to see this ever-increasing CO2 as it's driving us closer and closer to the point of no return, which, by the way, nobody knows when it is. So it's not that we know when the point of no return is and we can kind of go right to the brink and then come back. We could already be past it because nobody knows. Now, some of you may find it demotivating to think that we could already be past the point of no return, but I would hope that you're not demotivated, because I would hope that you think that even if we are past the point of no return, we have to do everything we can. We're morally obliged to do everything we can to try and turn this around before we get to this point where we enter hothouse Earth. Now, I'm just going to quickly show you a couple of quotes from Professor Jonas Rockström, which are a couple of quotes that I say quite often on my talks, because they are a really important thing for us to orient around. This is one of the leading climate scientists in the world, and this there was a report that came out in the UK from the Committee on Climate Change saying that, you know, at the going rate, the UK might as well prepare for 3 or 4 degrees of warming, which is insane. Like, we need to turn things around rather than prepare for that. So, as Professor Jonas Rockström said, who is like basically the world's leading light on climate change, the current most likely trajectory would leave us in a world that would likely support only half of the current human population. To put that into perspective, the coronavirus has so far wiped out, I think, about 0.006% of the population. Compare that to what Professor Jonas Rockström is saying about the burning of fossil fuels wiping out 50% of the population. This is a proper... I don't want to say that COVID isn't an emergency, but like, if you compare it to climate change, that is the emergency. And indeed, the consequences of a 4 degrees C warmer world are so terrifying that most scientists would rather not contemplate them, let alone work out a survival strategy. So how dangerous are fossil fuels really? Incredibly dangerous. So dangerous. It's something that the world has been really lulled to sleep about the danger of for such a long time, and we really, really need to turn this around. So I'm going to ask you one more question before I kind of go to the end, and that is this: when will we run out of oil? When will we run out of crude oil? What do you guys think? When are we going to run out? And for those joining late, thanks for coming. This is now coming towards the end of this Aim High Live. But if you've liked what you've seen, then do follow us if you are on Twitch, or if you're on our website, then do sign up for our weekly schedule, and follow us on social as well. I'll tell you about that later. But there are loads of teachers doing like a series of lessons that are supposed to be interesting and kind of inspiring, and also real. And that's kind of the point of this lesson, is that it's very real, and I'm not going to hide anything from you, and I'm not going to sugarcoat it. I'm just going to say it how it is. Okay, so Raptor is saying 30 to 50 years. 1 million Soths is saying in 2075. Maddie Hay thinks 12 years, or maybe 18. Jeff thinks maybe 100 years. 20 years. And Craftlaw is saying bye. And Japan Maple is saying, I think the amount of oil in... Oh, yeah. So Japan Maple is spot on. When will we run out of oil? We are not running out of oil. Nobody has any idea when we will run out of oil, and any predictions that it will happen soon, within a few decades, even within 100 years, are completely full of crap. And this is something that's been pushed around by the fossil fuel industry for such a long time, that we're running out of crude oil. We're not running out. We discover oil so quickly that even though we are using it more quickly than ever every single year, so every single year you would think that the supply is going down faster and faster because we're using it faster and faster, but every single year we also discover more oil and more ways of extracting it faster and faster, to such a point that the amount of predicted oil remaining under on the Earth goes up by 2% every year. Every year, the amount of oil that we predict is left on the planet goes up by 2% and has done for at least the last 10 years. And I'm not sure about data further back, but ultimately the idea that we're running out of oil is complete rubbish, and there is no way that we will ever run out of oil fast enough to save ourselves. Okay, so how dangerous are fossil fuels? Really, very dangerous. What can we do about this? I want to just, rather than leaving you with kind of nothing and just saying this is all terrible, I want to give you a few concrete things that you can do. So if you have any influence at all over the energy provider that is in your home, then I would really encourage you to either switch it yourself or talk to your parents, and try and spread the word through schools and universities and your workplace and whoever is watching, that everybody needs to switch energy provider to a green energy provider that only uses renewables for its electricity. So everybody needs to switch to green electricity. This is one of the simplest and most effective things you can do. A lot of people say, "Oh, it's too difficult to switch to renewables because it's not sufficiently in demand. It's a bit more expensive and so on." But if everybody switches to green electricity, and it wouldn't even take everybody actually, if only 5 to 10% of the population were like, no, we only will accept green electricity, and we don't want you sending any electricity to our house that is the consequence of fossil fuels being burnt, then things will start to change really rapidly, because suddenly the energy companies that aren't supplying green electricity will realize, everybody really wants green electricity and they're prepared to pay more for it. So therefore we need to supply green electricity. We need to invest more in solar panels and wind and so on. And anybody who tries to tell you that any renewable releases more fossil fuels than it saves is just completely lying to you. And all of that stuff has been debunked multiple times. And I would start talking about it now, we're running out of time. So the other thing I want to say is number 2, divest. So this is one that takes a little bit more research, but actually really not very much research at all. So if you have a bank account, then check to see what the bank account invests in, because a lot of banks still invest in fossil fuels, and all you need to do is just move your money away from that account. And it's a tiny change that makes a huge difference, because a lot of people think that when you put your money in a bank account, the bank is storing your money for you, but they're not. That's not how bank accounts work. When you put money in a bank account, essentially the bank owes you that money, but it doesn't necessarily mean that they have it. And they don't have it because they've usually lent it out to by investing in the stock market and investing in things like fossil fuels. So if they don't have your money, then they can't invest it in fossil fuels if they're a fossil fuel investor. So find out if your bank account invests in fossil fuels, if you have any funds at all, or your parents or friends or teachers or whatever have any kind of funds like pension funds or anything like that, then encourage them to just do a little bit of research. There's loads of websites out there that are starting to help people to discover this, to get people to divest from any kind of account that has anything to do with fossil fuels at all. It's a really easy thing to do, and that is one of the biggest differences that you can make. The final point is just to spread the knowledge. Keep this knowledge spreading and keep allowing people to know that there's a huge amount that we can do. We can really change the world if we all band together and we talk to one another and we share ideas. So thank you all for coming to this Aim High Live. I realised that I didn't take many questions in that last bit, because I was kind of talking quite passionately about fossil fuels and what we can do about it. So I'll take questions in a moment, but before I do, I just want to say again, thanks all for coming along. And if you enjoyed this and you haven't already, then please sign up for our schedule on our website, which you can find there, aimhigh.co. Follow our socials, which we have not started posting on TikTok, but we've got a TikTok, so do be one of our first followers if you want. And follow us on YouTube and Twitch if you're watching on there as well. And thanks so much everyone for coming, and I will see you all on Wednesday. I'm going to be part of Phil's live, so let me show you actually quickly what's if you haven't seen this poster already, this is the summer school that we're running. So Phil's become an author. So you can join Phil and basically write poetry with him. I'm going to join him on Wednesday for his live lesson. And do come along to some of the learning adventures that are coming up. And if you haven't heard about it already, we're going to do the big catch-up in the last 2 weeks of August, which will be loads of syllabus-based things to help people catch up going into year 9, 10, 11, 12 or 13. Any of which is if you're not in the UK, because we'll be doing syllabus stuff that will apply to loads of other countries as well. Then it is going to be ages, what is that? Like ages 13 or 14 up to age 17 or 18. But yeah, do come along to the big catch up, and thanks all for coming. It's been great to see you all. I will now take questions. So let's see what questions there are, and I'll stick around for a few minutes if you've got anything you want to ask. Do I know any green bank accounts? So yeah, the Co-op, if you're in the UK, the Co-op is really good. And I just saw Triodos, Maddie Hay posted. That's good. And Co-op and Nationwide Building Society. Yeah, Maddie's put a great list above of really good UK banks if you're in the UK. All of those look pretty good to me. In general, building societies are better than banks, and the Co-op is particularly good and always has been. And Triodos is a new one that is really pushing for better green investments. So in fact, Triodos is on my list to check out. I was going to check those out quite soon. Does anyone have any other questions that I missed? Charming saying that they've got green electricity, very good quality power at 230 volts. Yes. Okay, I think that was all the questions. Right. Okay, thanks so much all, and I will see you next time. Farewell. Do check out the calendar as well if you don't know what's coming up. I think my next solo one is on Monday. I think that's when I'm next on solo, but I'll be with Phil on Wednesday too. Farewell. Bye.